Salutations, mini mathematicians! Wow, you are flying through Module 4. Can we believe we're almost at the end? You've been doing such an amazing job. I'm so proud of you. And I've never doubted you. You've got this. Okay, so 4.2F, we're doing real-world problems and inequalities. Now that you are an expert at graphing systems of linear inequalities, we're going to write a system of inequalities that represents the context and provide possible realistic solutions. Possible solutions. Let's get started. Okay, so our first story is about Percy and his little kitty, not so little kitty, Lucky. So Percy's concerned about the food he's feeding his cat, Lucky. One of the biggest issues right now in our current age with domestic pets is obesity. It's really important to feed your fur brothers, sisters, and babies, your family, your furry family members, feed them well and exercise them well and, you know, treat them well. So we have to snuggle them and pet them and give them physical and mental exercise, and they make our lives so much better. So we want to do whatever we can to make their lives the happiest as possible. So back to Percy and Lucky. So Percy's concerned about the food he's feeding his cat, Lucky. The veterinarian recommended that Lucky's diet includes at least 30 grams of protein and at least 16 grams of fat per day. And Lucky should not eat more than 12 ounces of food per day, no matter how much Lucky whines for it. So at least 30 grams of protein and at least 16 grams of fat, and not eat more than 12 ounces of food per day. Well, Percy's going to choose between these two cat food types below, and his idea is he's going to mix them. So give Lucky a little bit of food X and a little bit of food Y to meet the veterinarian's recommendations. So let's see, food X, each ounce provides 2 grams of protein and 4 grams of fat. And food Y provides 6 grams of protein and only 2 grams of fat. Fat is part of a healthy diet because we need it to survive and have healthy bones. Okay, so Percy wants to vary Lucky's diet within these requirements, and he needs to know what his options are. If we let X equal ounces of food X and Y ounces of food Y, answer the following questions. I know, so original with the variables this time, right? Okay, so the first constraint from the word problem was Lucky cannot eat more than 12 ounces of food per day. So right here, 12 ounces of food. Well, what are we feeding? We're feeding X ounces of food X and Y ounces of food Y. So that means X plus Y needs to be less than or equal to 12. Then the next restraint is about protein. We need at least 30 grams of protein. Well, if we're feeding X ounces of food X and food X has 2 grams of protein per ounce, the total grams of protein that we are feeding is 2X. Plus, if we look at food Y in 1 ounce gives 6 grams of protein, and we're feeding Y ounces, so that's going to be 6Y. At least 30 grams. So could we give 30 grams? Yes. Could we give less than 30 grams? No. Can we give more than 30 grams? Yes. So this amount here that we added up is greater than or equal to 30. So it's really nice to have that conversation with yourself. Can I have equal to it? Can I have less than it? Can I have more than it? Okay. And the last restriction here is about the grams of fat. So needs to include at least 16 grams of fat. Well, food X has 4 grams of fat, so we're serving X ounces, so we're going to have 4X grams of fat plus 2 grams of fat per ounce from food Y, and we're feeding Y ounces, so 2Y grams of fat compared to 16. So at least 16 grams of fat. I know it might seem like you want to use the less than or equal to symbol, but think about this is how many grams of fat. So this amount here, can it be greater than 16? Yes. Can it be equal to 16? Yes. Can it be less than 16? No. So this is also greater than or equal to 16. Perfect. Let's take a look at part B. Part B says graph your inequalities on the coordinate plane below. Label all your lines. Notice they already labeled our x and y axis very neatly. We're going to shade the feasible region that represents the possible solutions and list 3 possible solutions, diet solutions for Lucky to make sure Lucky lives a long and happy life. Okay, well, let's look at inequality 1. X plus y is less than or equal to 12. To rewrite this in slope-intercept form, what we're going to do is subtract x from both sides. So I'll have y is less than or equal to negative x plus 12. And we know that this is going to be a solid boundary line. And we are going to shade because this is less than below. Okay, so I'm going to graph the y-intercept. I'm going to go down 1, left 1. And before I graphed, of course, I checked to make sure my x and y axes went by single units, and they do. That's really important before you start graphing. Grab my ruler. This is solid boundary line. I'm going to label this as 1, and we're shading below. I'm not going to do too many because I want my graph to be nice and neat. Okay, let's take a look at inequality 2. 2x plus 6y is less than or equal to 30. So I'm going to subtract 2x from both sides, and I'd have 6y is greater than or equal to negative 2x plus 30, and then divide every term by 6, and I get y is greater than or equal to 6 over 2 is 1/3, and it's negative, so negative 1/3 x plus 5. This is also going to be a solid boundary line. However, this is greater than or equal to, so we are going to shade above. Okay, so 5, down 1, right 3, down 1, right 3, down 1, right 3, down 1, right 3, and down 1, right 3. Whew, glad it fit on my x-axis. Remember, this is solid boundary line, and we are shading above. I'm not going to worry about shading over here because obviously there's no feasible region to crosshatch there, so we're not going to worry about that. Oh, so I'm seeing a nice triangular shape. We have one more inequality to graph. And this one is 4x plus 2y is greater than or equal to 16. I'm going to subtract 4x from both sides and divide everything by 2 and get y is greater than or equal to negative 2x plus 8. This is going to be solid, and it's greater than or equal to, so we're going to be shading above. I really like making these notes to myself just so when I get to the graph, I don't make a silly mistake. Okay, so here's 8. I'm going to go down to right 1. Beautiful. This is a solid boundary line, and it's shaded above. But notice I don't really need to shade over here above. I just need to worry about the feasible region and to make sure that it's obvious where the feasible region is, because just looking at it, it's kind of hard to tell. I am going to color in with my highlighter marker, so it's very obvious where the feasible region is. Okay, so the last part of this question asked me to give 3 possible solutions, and your answers will vary, but if we take a look, I like the number 4, so 4 ounces food X, and if I go up to my feasible region, I could have 4, 5, 6, 7, or 8 ounces of food Y. I'm going to pick 7 ounces food Y. So we just have to pick values that are in the feasible region. When I looked at 4 and 4 looks like it's there, but it's like super, super close, I'm probably not going to pick something that is, kind of sus, Okay. So We need 2 more, at least 2 more, because said we want 3. Okay, well, how about 8, 4? So 8 ounces food X and 4 ounces food Y. Remember, if you're picking points on a boundary line, make sure the boundary line's solid. Also, if you're picking points on the boundary line, make sure it actually is a point graphed on your boundary line, because sometimes they can look really close, but they're not. For example, on my green boundary line 2, it really looks like a point could be on there, but it's not quite there. For example, it looks like it could be on the line, but it might not be. So I'm just going to pick ones that are obvious and true. Okay, I need 1 more. Let's use 2 ounces of food X. And if I go up from 2, let's use 6. 6 ounces of food Y. Obviously, there's so many more combinations you could pick, and your answers will vary. Let's keep going. So happy for Lucky. Okay, so the next problem is about Elena wanting to go on vacation in Hawaii. Lucky girl, huh? Okay, so taking a look, and obviously she didn't have to quarantine. She just wants to stay there 7 days. So Elena wants to spend no more than $900 on hotels while vacationing in Hawaii. She hopes to stay at the Hyatt Resort at least 1 night and at the Coral Reef Hotel for the remainder of her stay. The Hyatt Resort costs $150 per night, and the Coral Reef Hotel costs $100 a night. If she wants to stay in Hawaii at least 7 nights, how many nights can she spend at each hotel and still stay within her budget? Define 2 variables to represent the situation. Well, the 2 unknowns here are the number of nights at the Coral Reef and the number of nights at the Hyatt. So we're going to use that number nights at Coral Reef Hotel. And I'm going to call that X. Obviously, it doesn't matter if you call one X and one Y. I do want to use X and Y here just so it's consistent when I go to graph. Number nights at the beautiful Hyatt Resort. Is that the place with the turtles? With like the lagoon? I think it might be. It's either the Hilton or the Hyatt that has the turtles. They're just so big when you get up to them. Okay. Focus. Use your variables to write 3 inequalities that describe the constraints of the situation. Explain the constraint of each of the inequalities that represent. Okay, well, what's the first thing we talked about? No more than $900. So $900 budget on hotels. Well, how much money is she going to spend staying at the Coral Reef? It's $100 a night, and we're staying X nights. Oh, 100X. Perfect. Plus, well, how much money is she going to stay at the Hyatt Resort? Well, how much money will she spend staying there? It's $150 a night, and she's staying Y nights. Good job, 150Y. And her budget's $900. So this amount added together, could it be equal to $900? Sure. Could it be greater than $900? No. Can it be less than $900? Yes. So this amount can be less than or equal to $900. What's another restraint that we have here? Oh, she wants to stay at the Hyatt Resort at least 1 night. Stay at the Hyatt at least 1 night. You know, treat yourself. She's earned this vacation. So number of nights at the Hyatt, that's Y and 1. So the number of nights at the Hyatt, could it be equal to 1? Yeah. Could it be greater than 1? Sure. Could it be less than 1? No, we have to stay at the Hyatt. So Y is greater than or equal to 1. And the last constraint is how long her stay is going to be. She wants to stay in Hawaii at least 7 nights. So 7-night minimum in Hawaii. So, well, that means however many nights at the Coral Reef Hotel plus the number of nights at the Hyatt needs to be, well, could it be equal to 7? Sure. Could it be less than 7? No, we're going all the way to Hawaii. We want to stay at least a week. Could it be greater than 7? Yeah, let's extend this vacation. Great job. Okay, so the next part asks you to graph your inequalities on the coordinate plane, label each axis and all of your lines. Shade the feasible region that represents the possible solutions. So we have already said that the x-axis, we defined x as the number of nights at the Coral Reef Hotel. And the y-axis, I'm not going to write sideways, number of nights at the Hyatt. Awesome. Okay, go ahead and finish up the rest of number 2. Pause the video, finish number 2, and we'll go over the answers when you're done. Okay, let's see how you did. The first thing that I did when graphing these is I rewrote them in slope-intercept form when needed. So I had y is less than or equal to negative 2/3 x plus 6, y is greater than or equal to 1, and y is greater than or equal to negative x plus 7. When I graphed them, of course, I labeled my inequalities, my boundary lines 1, 2, and 3, matching with the labels I have here. And I had this feasible region. It looked like a triangle. So which option would give Elena the most number of nights at the Hyatt Resort? So the Hyatt Resort, remember, is this green line. Anything above the green line is going to be talking about the Hyatt Resort. So taking a look, I wanted to look at the largest y value in my feasible region, and that's going to be right here at 3, 4. So 3 nights at the Coral Reef and 4 nights at the Hyatt is going to be the most nights at the Hyatt Resort. Which option would give Elena the longest stay in Hawaii? Well, the boundary line talking about the length of the stay is boundary line 3, x plus y wants to be greater than or equal to 7. So I wanted to be above this maroon number 3 line. And taking a look, I started looking and adding them up. So 6 plus 1 is 7. Here, 6 plus 2 is 8. And then I kept moving over. I said, well, this is 7, 1. That's still 8. Here is 5, 2, and that gets me 7. So I guess we could do 6 nights at the Coral Reef, 2 nights at the Hyatt, or 7 nights at the Coral Reef and 1 night at the Hyatt. They're both going to get me 8 days. So 7, 1. And it says which option would be the cheapest. So I had a tough time thinking out, are they talking about these 2 options or just option in general? So here I just thought about all the options in general. What's going to be the cheapest? So the options below line 1, which is the pink line, light pink line. So here, the farthest below is 6, 1. So 6 nights at the Coral Reef and 1 night at the Hyatt is going to be a total of $750, which is the cheapest she can be there in Hawaii with her hotel budget. Great. Awesome job. Okay, let's go on to our last problem. Our last problem is about Rory, and Rory likes her job as a babysitter, but it's only $3 an hour. I know. She's getting, I don't know, scammed. But she's been offered a job as a tutor, and it pays, you guys, wow, $6 an hour. Hey, it fits on your coordinate plane. Just maybe this is back in the day, when $6 was a lot of money. Because of her school, her parents only allow her to work a minimum of 15 hours per week. How many hours can Rory tutor and babysit and still make at least $60 a week? Well, we have to define our variables that represent the situation because we're talking about how many hours tutoring and babysitting. We're going to set hours spent babysitting as X, and we're going to set hours spent tutoring as Y. Awesome. From here, I need you to use your variables to write two inequalities and also explain the constraint that each of your inequality represents. Then I need you to finish C, D, E, F, and G. And we will go over those as soon as you're done. So you're going to be finishing up all of number 3, and we'll go over them when you're ready. Okay, let's take a look at how we did. So one of the constraints was she needs to earn at least $60. So 3x plus 6y is greater than or equal to 60. $3 per hour babysitting at X hours. $6 per hour tutoring at Y hours. It has to be greater than or equal to 60 because she wants to earn at least $60 in a week. She can work at most 15 hours. So her parents will let her work 15 hours, but no more. So X plus Y, the number of hours spent babysitting plus the number of hours spent tutoring, has to be less than or equal to 15. Hey, why does X and Y have to be 0 or greater? That's because we're talking about hours spent doing an activity, and you cannot work negative hours. So X has to be greater than or equal to 0, and Y has to be greater than or equal to 0, which are the Y and X axis, respectively. So from here, we needed to graph all 4 inequalities and label them. I labeled them just with numbers, 1, 2, 3, 4, and with colors. So from here, we made this nice triangle. So 2 options that allow Rory to make at least $60 a week. There's many options here. Please double check that your hours babysitting, hours spent tutoring are inside the feasible region or on one of the boundary line points. So I used babysit for 2 hours and tutor for 12 hours. And then I used babysit for 5 hours and tutor for 9 hours. Okay, is there an option that allows Rory to spend the same amount of time babysitting as tutoring? If so, how much money would she make? So I started looking, I was like, okay, 1, 1, obviously, like the lower numbers weren't working. So I started over at 10, 10. Oh, 10's up here. So I started working down and I found 7 to be in the feasible region. So 7 hours babysitting and 7 hours tutoring. And then I just multiplied 7 times 3 and added to 6 times 7, which gets you a total of $63. The last question said, which option allows Rory to make the most amount of money? So the most amount of money is going to be up here where she spends all her hours tutoring and no hours babysitting, and that would be $90 because she makes $6 per hour tutoring. Great job, mini mathematicians. You are doing such a great job. Keep up the awesomeness, smile, and I will see you next time.